Hello and welcome to Rust Planet. I'm Akshaya and today I will be covering the topic about generative art. So, have you as an individual in general, you might consider yourself to be not very creative. I mean, you might have friends or colleagues or other people that you know, or even random people who make beautiful art. I mean, they draw really well, they sing really well, they dance really well, they do a bunch of different creative outlets. And you as a person might think to yourself that I am actually not that creative. I mean, I usually spend my time coding. I don't really get into the creative space where I make artwork. Or maybe you're just an individual who's trying to expand your horizons on what exactly you know about coding and its relation with art. Um, and that's where this amazing, really fascinating concept of generative art or creative coding comes into play. Um, Generative art in general is just all about creating all sorts of like stunning visuals, audios, videos, any interactive artworks or pieces using code and algorithms. And actually, it's very cool to think about. I mean, the concept of being creative and code is not necessarily something that's really aligned in most people's thoughts, which is why this is such an interesting topic because you take something so um, I guess, logical as code, but you make art out of it. So, generative art is generally a form of art which is done using algorithms, using any sort of math or equations, and it's usually done with the assistance of your computers and software. And as you can see, that there are a bunch of different examples for how creative you can actually get with creative coding or generative coding. These are a few examples of exactly what you can do with nothing but code. There is no sketch, there's no pens or markers used in any of this, even in the digital space. It's just all done through code. A really good example of the most simplest form of, I think, generative art could be if you're a Python user, there is this library called Turtle, which basically is the most basic form of generative art. It's just a turtle that you give directions to, that you go left, you go right, you turn 90 degrees, you turn 360 degrees, and it draws a line in the process, possibly. So this is basically what generative art is. Of course, there's different types. It's not just static like with images. You also have different types of art like music. You have audios, you have interactive videos where you as an individual get to interact with it. So generative art is just, all about creating visuals. But how exactly does it translate from code to like artwork? I mean, what exactly is artwork is essentially the question we're asking here. So first things first, generative art is just all about algorithms and rules. So there's a lot of different things like your maths and the magic of maths that you use, where you determine your shapes, you determine the structure, the behavior, um, and all of these different aspects about the art that you're creating. So it can be really simple, where you just draw like a square or a circle, and it can be something really complex, like the images that we had seen before. There's also a lot more, like how you incorporate randomness and variation into a lot of your artworks. So art is not static. I mean, art is not defined. Art is not something you can just, as an individual, know exactly what happens in art. That's why it's creative. It's something that comes out from you as an individual. So you sort of try to mimic that creativeness or that humanness in art by introducing randomness and variations in it. Generative art is also is usually done using your computers and your systems, etc. You have a lot of programmed instructions like your data, and you have like basically you have a set of rules with which your systems follow. Art can or the generative art can also be really creative, I mean, and interactive, basically. So a lot of your generative art pieces respond to you. So you actually interact with it and you give its input from your environment, and it's like kind of like your part of the creative process, right? You're part of what's happening exactly. Art is also data driven. Sometimes you can actually create art from just the data that you have, the real world data. So, for example, you could have information about the climate or the weather, right? and using that different data, like, oh, these are the days where it's been sunny, these are the days where it's been cloudy. All of this different information can actually be used as data to feed into the generative model process to result in art. And that's really cool, right? That's really cool where art can actually have a more logical side to it. So now that we've talked about the general structure or the basic concept of what generative art is, let's get more into the programming. So generative art is actually pretty versatile with how exactly you can make these pieces. They are not specific to just one type of language or one type of programming language. Instead, generative art and programming actually blurs all the lines between art and technology and can be done in multiple types of different programming languages. Simple examples like be in Java, where processing is basically the go-to tool that you use for generative art. You can create really cool, mesmerizing art pieces that can sometimes evolve over time. In Python, like mentioned before, you have different libraries, like you can use Turtle, you can also use things like Pygame and Cairo and processing, etc. And these are like the most commonly used libraries in Python. You also have in JavaScript for all the web enthusiasts. JavaScript is really good with generative art using something called p5.js. With just a few lines of code, you can actually make interactive generative art. That is pretty cool. You also have other languages, which other than the mainstream ones like Max or MSP and Pure Data, that is usually used for something like for audio-visual experiences. So there are multiple types of different programming languages you can use for making this generative art. But right now, what I want to focus on is Rust, which is the programming language that we're going to be using to further our understanding of how exactly generative art happens. Now let's talk about Rust in generative programming. Let's see how exactly Rust fits into the generative art world. Rust as a programming language is actually very powerful and can be used to express our different forms of art in from code to actual art. Um, let's see why Rust. I mean, you have all these different languages, so why exactly are we going to talk about Rust in the generative world? So Rust is actually a performance powerhouse. Rust is renowned for its performance. That means you can tackle computationally intensive art projects with a lot of confidence. It also is very safe. So Rust actually guarantees different safety features. It's like a safety net for your code. There's no worrying about any sort of crashes or like really commonly caused errors that happen when you're programming. And there's a lot of graphics that can be included in Rust, like the library or the framework that we'll be talking about called Nano. You can have different types of visuals like 2D, 3D visualizations, different interactive art pieces, etc. And it makes sure that, it's very pretty to look at. Then you also have different concepts of multi-threading. Many generative art projects involve a lot of parallel processing or working with multiple threads, and Rust helps in dealing with this. There's also cross platforms. Your generative art is not limited to just one single platform. It has a lot of portability in the way that it can be used in your high-level devices like your desktops. It can also be used on the web. It can be used in embedded systems, etc. You basically have a large audience for which you can cater your artistic needs to using Rust. It also has interactivity. It's basically Rust is very good for interactive artworks. So interactive artworks actually require a lot of computation, they require a lot of complexity, and because Rust is such a simple dynamic language that can deal with a lot of these intensities or intensive operations, that it's actually great for this. There's also real-time renditions. You can have your artwork evolve over time or react with you in real time, and Rust is really good for this. There's also a lot of community benefits to Rust. So Rust is a whole open source language. And because it's open source, there's a lot of people that contribute to the community. You can find a lot of different types of models or different types of art pieces being made by these different people. And you also has a great forum where you can go and interact with different people about what you think is good art or bad art. And so let's go a little bit deeper or more specific into what exactly we'll be using as a sample to create artworks using Rust. This can be done using something called Nano. Nano is an open source creative coding framework. Basically, a framework can be thought of as a collection of different building blocks that basically help to accomplish your goal. Your goal here is generative art. It's actually designed so as to make it very easy for different artists, designers, developers, whoever's interested in this world of interactive art to create it using a language that they are comfortable with or a language that they know pretty well. And Rust has its benefits, so this is what Nano is. So let's look more into how Nano exactly works. There's actually a bit of a small framework that helps you understand what are the main components in the code, in the Rust code that we're going to be looking at. So we can see that the general framework for this framework and these paradigms can be split into three different types. So Nano in general has a more model view controller pattern. That's like the actual approach that is being used here by Nano. So what does this exactly mean? So the model view controller, as you can see, the model basically describes more about the internal state of what exactly is happening in the code. So, should a window open? What exactly is happening within the computer? That's what the model deals with. Next is the view. The view is basically what are you presenting, how to present a specific model or whatever you're trying to present. How do you present it? That's more about the view. So an easier way to put it is your screen. So how exactly are you presenting, or how exactly are you showing these different artworks or the different changes that are being made? Next is the controller. So the controller talks about how to update your model. So how do you update it at certain events? So a good example in the whole computer screen or computer screen model, it would be your mouse. So how exactly are you making changes? How are these changes happening? How are they being updated? It relates to more of your mouse or the way you use your system. So again, the model is the computer, the view is the screen, and the controller is your mouse. So how do you control it? How is it being shown? How do you present it? And what's actually happening inside? Just like the general model of how exactly the Nano framework is based upon, what sort of approach it uses. So now let's look at a very basic, coming to the actual code in Rust, let's look at a very basic structure of how we can represent um, our approach or the general structure that we had seen before that I'd explained. So in this, we can see that we have this line of use nano prelude, which basically includes all of the different functionalities that are required for implementing this sort of code, which is how we write it in Rust. So this is all in Rust. Um, yeah, so the next we have the struct model, which is basically a structure representing the state of the program. So like we had mentioned before, you have a model event view sort of infrastructure that is being used in Nano. So this deals more like about what exactly is happening, what is the state, what is currently happening in the Nano, what is currently happening right now. So in the beginning, this code is actually a very simple code that essentially just opens a window. There is nothing being drawn, there's nothing being taken from it. There's nothing actually happening other than the fact that it opens a window. So in Rust, you have the function main. Your function main is essentially where the code actually happens. This is where your code starts and your code ends. So anything that happens within the main is what actually happens in Nano, in Rust in general. So over here you have your Nano where you have your app, your event, and your simple window and run. So the way each thing actually corresponds to one thing. So your model is where you're actually having your code being run. Your event is what actually is going to be happening. Your simple window is in view. So this basically talks about how you have your window being opened. So this is a function for that. So there's a lot more specificities that you can go into as you progress with learning about Nano. And run. So run just means run the code that is there above. So as you can see, we actually have defined each paradigm or each functionality or each concept into a function in itself. So you have the model. Inside this model, you have your application that you'll be running, which is with Nano. Inside your model, you actually have the model structure, which you will be returning. You're actually not doing anything here. You don't have anything under event, you don't have anything under view because you're just opening a window. So if I run this code, you can see that a window is being opened and there is nothing being displayed on this window. That is because opening a window is more of an internal functionality than it is something view or event based, which is why you've actually given your model structure over here. So now we can look at another example of how exactly we can just have a very simple window that we open, but this time we'll have like a blue background. We're not going to make it complex, or we can make it any color that we want. So basically now here we have the same nano payload. Again, this is like a base that you need to include so that you can actually include it, any of the functionality that is required for nano. You have your function main, which then has a sketch function. So there is a function being called here that is actually trying to open your window. So basically anything that is defined within this view function will actually be represented on the window that is there for us, that opens up like last time. So now here we have our draw variable, which is actually sort of defined using app.draw, which is kind of like it's a canvas type data type that is actually made provided by Nano itself. This is why we included everything in it. So this canvas like data type. So now draw itself has different types of functionality. So if I were to go here, and you can see that there is a lot of different functionalities that are there within the draw variable. And this is because we have included it, or we've declared it as a canvas type of app.draw. Now over here we have our draw background, which basically defines that the background of the specific window that we have will be blue in color. So I actually can make this any color that I want. So if you want for yellow, oops, my bad. Go for yellow. You can do yellow green like that's there. You can do normal green and green yellow. You can do red, etc. So for now, I'm just going to do pink because it is one of my favorite colors. So I'll just do pink, and this is just a everything needs to be put into frame. So every function, every anything that is being used in this actually has genuine documentation and further explanation of exactly what's happening here. So I'm just giving you an overview of how you can use Nano, or how you can actually use the Rust code to make some like really basic art pieces right now. So if I were to just save this and run it, and there you go. You have a pink colored background that is being generated. So if I put anything else like blue, red, whatever, you will have a corresponding color show up. So this is another example of how you can actually use Rust to make like a very simple sketch, Nano. So a sketch is actually a lot simpler than Nano. So a sketch basically is how you define this whole function. Okay, this whole program is written in the concept of sketch. A sketch is something very simple. It's very easy. You just doodle in it. There is no states. There's nothing complex to actually think about. I mean, when you relate this code to what we've seen before, this is a lot simpler. I mean, you just have your sketch view. So basically, the sketch view dot run is actually a shorthand for what we had seen before, where we had opened the window. So we had an open window with the event, and we had view. So we had that, I think, when we had seen it before when defining. So this is actually a very simple shorthand for it. So within our view function, I've actually defined again a draw that is app.draw. So it's a canvas-like data type being defined again. We once again have our background, which is of now a color called plum. But now there are some new things like drawing an eclipse. So actually draw dot eclipse, sorry, an ellipse really leads to an ellipse being drawn. You have a rectangle, you have a circle, you have a square, you have multiple shapes. So again, it's very simple on how to actually draw certain things. So I'd also like to show two things. So suppose this line, we don't have this line, right? So we are just ignoring this for now, right? So if I was to just run this as it is right now, then we'd have a very simple art piece. Oh, wait, I mean, it's essentially just a screen with an ellipse in it. I mean, if you want to get accurate, I guess you could make it red and white, and you'd have the flag of Japan, which is technically an art piece. And I mean, it's a flag. So, but if you want something, suppose you want to add another ellipse, right? You want to add something else because maybe I want to make it a face and not just a single dot in the middle. Now, if I were to do that, okay, so let's just close this window because we don't really want this. So now, okay, I'm just gonna, you know what? I'm just gonna copy paste this thing once again, and it's gonna be, I mean, sorry about that. I'm just gonna what, copy paste it. I want two ellipses, and I want this one to be red in color, and it's gonna be very simple for me. I mean, I just want two ellipses, and it should be that simple, right? So I'm just gonna run this. Um, and, I'm just going to get two ellipses on the screen. But clearly, you can see that is not the case. You don't get two separate ellipses. Instead, you got a red ellipse. And you might be wondering what exactly is happening here. I mean, where's the other ellipse? I mean, one's blue, one's red. Basically, it's overlaying on top. So the issue here is that we've actually not mentioned anything about the position of where you want an ellipse. I mean, sure, if I want a face, I want my one eye here and one eye here, but I've not actually mentioned that here at all. I've just said that it's an ellipse and it's of this color, and that's about it. So what happens, or how do I um, include, or how do I make this into two different circles? And this is where we talk about the coordinate system. So we have a very simple window, and we talk about the different coordinates that are actually there within your within essentially the window size and the number of pixels and your ratio and how exactly you're representing it. So this is a very simple, um, uh, easy dimension to understand. You have it as 200 on top, 200 on bottom, and we have 0, 0 that's down the middle. So this is like along the XY axis. So we can actually represent this idea of the coordinate system in our code. Um, so now we're back, and you can see that according to the coordinate system that I had taken before, we had taken a point of 100, 0 and 100, 0 again. So now we're, sorry, 100, 100. So now we have this ellipse. So I have, again, have the color here, you have a dot color, you have the same thing, except this time you have your XY axis and your width and your height, which are now dimensions being mentioned so that this is not going to be the same as this. This, because it's already defaulting at 0, it's like right down the center. So now you've actually mentioned different coordinates over here. So if I were to run this now, you can see that we have two circles and they are of completely different, they are not overlaid on each other. So like we had seen before, it does not mean that the blue circle wasn't there, it's just that this was sitting right on top of it. So I guess this is a very simple example of how exactly we can make art. So using just this in itself, I can show you that we can actually create art with it. So I've actually created with nothing but the simple concept of just circles and having coordinates. I've actually created my masterpiece of I guess that's Grimace from McDonald's looking at me, um, which is a very simple understanding of how exactly Nano can be used to make art. I mean, it gets much more complex, obviously. There will be different things like changing your heights, your widths. You can get images in, you can have different 3D models and different sorts of artwork that's possible. But that if you want to know more about Nano and more about Rust and how it's used for Nano, there actually is a documentation that is provided online for it. It's just called the Nano doc for, if you just search Nano, it's going to show up and you have the document in it, where everything is very clearly explained and goes more into detail about how you can use Nano and Rust for generative art. And if you have any doubts, you can obviously post that in the comments below. And the basics, or just an introduction, a very general introduction on what generative art is and how Rust can be used to make generative art. Thank you so much for watching this video. If you have any doubts, feel free to comment it below. And I'll also be posting a link to Nano and its documentation, and also the Rust documentation on how you can use Rust for reasons other than generative art as well. So that's about it. Thanks for watching. Bye.